Okay, take a look at this function, y equals x cubed minus 5x squared plus 10. Now, this is a third degree polynomial function. It goes down forever on the left and up forever on the right, so this function has no absolute maximum or minimum values. However, you'll notice that this function has two terms, and at the vertex of the terms, and at these locations, the function doesn't get any higher, again, just in the immediate area. So let's take a look at this point here. And this type of point is called a local maximum. And basically, a local maximum is a point where that there is some region to the left and to the right, such that of all the points to the left or to the right within this region, this is the highest point. Also, what we should notice about this point is that if we drew the tangent line at this point, that the slope of the tangent line would equal 0, which means the derivative of the function equals 0 at this point. Now, let's take a look at the vertex of the other term. So, here's the vertex of the other term, and this is called a local minimum. And again, same idea. There's some region to the left and to the right. So with everything within this set of points, this point is the lowest point. So that is a local minimum. And once again, if I was to draw its tangent, not the best line ever, but the slope of this tangent line is 0. Or, another way of saying it, the derivative of the function is 0 at this point. So, to find these local regions where the max and the min is on these local regions, we need to set the derivative to 0. So, I'm going to go to the function over here and just make it larger so you can see my writing, and take the derivative. Y prime equals 3x squared minus 10x. And I'm going to set this equal to 0. This one's fairly easy to solve because I can solve it with factoring. Greatest common factor is x, leaving me 3x minus 10 equals 0, which gives me one location, x equals 0, and the other location, 3x minus 10 equals 0. I can find the x value. 3x equals 10. X equals 10 over 3. So these are the two x values of my local min and local max. Clearly, my local max is going to occur at x equals 0. To find out how high or what is that maximum value, that local maximum, I need to plug that into the original function to get the y value. Well, that's pretty straightforward because in this formula, x cubed minus 5x squared, where x is 0, is going to just 0 out, and y is going to equal 10. So what I can say in writing is y equals 10 is a local maximum at x equals 0. Now, the other point, the local minimum, we're going to find by plugging in 10/3 into the formula. Now, with this, I'm going to use my calculator, and it's perfectly good to use your calculator to find these values. And I've got, actually, I'm going to do a little shortcut. 10 divided by 3, I'm going to store as my x value. That way I can write less. And I have x cubed minus 5x squared plus 10 is going to give me my y value. I do not want a decimal approximation. So, number one, put my answer as a fraction, gives me my exact answer, negative 230 over 27. So I both have a decimal approximation, negative 8.152 if I wanted to round it to the hundredth place, or the exact answer, negative 230 over 27. And again, I can say that negative 230 over 27 is a local minimum at the x value 10 thirds.